We're in business. Right. There we go. That table there has to be dead easy for you. If it's not dead easy, you simply don't know enough of this topic. But before we hit that table, let's press that button, yeah. What you need to squirrel away someplace on the exam paper is this triangle. Oh, I don't like the black pen. What's happening? Nothing's working this morning. My pen's too thick. I like a nice thin, delicate pen.
It's easier to see.
Is it easier to see?
No, not that one. I reckon the little one.
I know it's on the board, but I want it on here.
We're like it for the
Right. Here we go. Here's what this topic's all about. Atoms, molecules, ions. They are the only particles that you need to be thinking about. Those particles have got forces holding them together. Forces between the particles. The forces between the particles will, I've spelt particles wrong, but never mind. Forces between the particles will influence the structure as well. But once you know what the particles are, once you know what the forces are, you can then begin to say something about the properties. And the properties that you absolutely need to know about are things like melting point, conductivity, solubility in polar or non-polar solvents. And the last ones were what you're doing with your video project. That's your starting point. Now, in and around that triangle, you can hang in a whole lot of other stuff that you should know about. But that's the basic. And they'll always test that basic. So if we go back to this here, that table only asks for the same information. Now, I reckon it's easier to follow the information on a triangle, because you can follow the triangle round, everything's linked. I reckon it's more difficult to make sense of it when it's on the table. But let's look at how we'd complete that. Now, before we go any further, I reckon that question is far too easy. I reckon they shouldn't have given you that column there. You should have been able to fill that stuff in anyway. But anyway, let's go through filling it in. Types of particle.
Atom.
It's atoms. We might be a bit more specific and say metal atoms. We'll just go down the particle column first of all. Zinc chloride. The name should tell you that that's made up of ions. The name should indicate that that is zinc attached to chloride ions. Yep, it's ions. It's an ionic compound.
These guys are sort of mucking around in there.
I can't deal with them just now, Rob. I'm doing something a wee bit different. I'm sorry.
Alright, you guys sit down in the corner, please.
The hazards of trying to do some teaching without interruptions. Never mind. You should immediately know the moment you see water that it's a molecular substance. The chemical formula tells you that H2O. There's no metal atoms in there, no metal ions in there. It's not ionic. It should be apparent to you that it's probably molecular. So the types of particles, it's told you it's made up of molecules. You don't even need to think for that, for goodness sake. And then diamond. Now if I just forward to this thing here again, I can simplify everything down as far as possible, but ultimately you've got to know stuff. And some of the stuff that you absolutely have to know about, you need to know about the structure of diamond, you need to know how the carbon atoms are put together. You're not going to have to empirically work out why diamond has got its structure and its properties. You'll know that because you'll have learned the structure of diamond. The other allotrope of diamond, graphite, you will also know about that. And that's chemistry at its most amazing. Diamond, the hardest material in the universe, graphite, one of the softest. And both materials are made up of carbon atoms. They choose those two examples because they're brilliant examples of what effect the type of bonding has on the structure and properties. And you will also know about quartz. And quartz isn't too dissimilar to diamond. So you will know about that stuff. You'll go into the exam with that in your head. And so when you see diamond down there, you know straight away that it's carbon atoms and that it's an extended covalent network. Okay, so anyway, the description of the bonding. On one level, you could say it's metallic bonding. Now that's pure dead brilliant, that is. But that'll probably get you achieved. What you need to be able to say, or what you need to have, is a sentence or two up your sleeve or concealed any place else that will say a little bit more about what the type of bonding is. The essential thing about metallic bonding is that it's the forces between delocalized electrons. Forces between delocalized electrons and the metal nuclei. And maybe we could, I'm constricted by the space, but in actual fact, it's not just forces. There's another two words we'd probably put in there, strong electrostatic forces. It's always electrostatic. So it's, the strong electrostatic forces between the electrons, the delocalized ones. Now, you know that. You know how to draw the diagram to illustrate metallic bonding. But you need to have a sentence in there that will explain it. Zinc chloride, ions, ionic bonding will probably get you an achieved tip somewhere, I don't know. But it's not really good enough. You should be able to say strong electrostatic forces, strong electrostatic forces between ions. Alright, there's the sentence that you use. Don't go into the exam making those sentences up. Have them really clear. Write them out umpteen times. We'll practice that as we get towards the end of the year. But this is what we're moving towards now. Not just being able to talk about it and get some half-baked ideas down on paper. It's about being really concise about what you say. That's beginning to become quite important now. Okay, what do we say in here? Help me out here. Isaac. Van der Waals.